to, I think it's the last talk of today. So I'm sure you're all pretty tired, but I appreciate you taking the time to come and listen to me talk. And my name's Joshua, and I come from what I call kind of a different world. My background is actually aerospace engineering, GNSS engineering, or GPS, as what it's more commonly known. And what we're doing at my company, NSL, working with organisations such as the European Space Agency, Google, and is trying to introduce what will be the new realm of navigation technology for smartphones. Now, I first pose a question: what do we think of when we initially speak about Android location services? So you've essentially got a device, you've got Google Maps, and you're going to have some user location being enabled with it. You've got probably a few buttons that you press to enable those sorts of services to come on. But under the underlying surface, it's part of very much a much bigger ecosystem. You've got satellites sending signals down to a smartphone device and back again. You use technologies like wireless LAN, cellular towers, accelerometers, gyroscopes, digital compasses, smartphone cameras are now being used, all to achieve a navigational position, or essentially what you get out of the Android API of a longitude and latitude that you can use in any sort of application, be it for fitness or for marketing purposes and based on geolocation, many different things. But the underlying core component of this is what we call Global Navigation Satellite Systems, but also known as GPS. Now, GPS is actually purely the American system, and what's happening at the moment is we've got regions across the world are introducing their own satellite navigation systems, and this is enabling much higher accuracies to what you can initially see inside the smartphone. As a very simple explanation of how GNSS works, you've got a location fix somewhere on the Earth. You're getting a satellite bouncing a signal between a smartphone, recording some time data, and using at least 3 of them, knowing the distance between those satellites, you can work out exactly where you're located. However, of course, when you're looking at particular apps, you've got a much more difficult environment to contend with. In the city, all of these buildings are actually blocking out the signals, or they're bouncing the signal as it travels down to the device, posing a much bigger problem. And that's why in the city environment you reach your blue dot, essentially, on your Google Maps screen is bouncing from different sides of the road. Might even, when you first switch on Google Maps, it might place you several blocks away from your original position. So it's quite a challenging problem, but it's changing at the moment. The technology is improving. We've got more satellites up there. But another key technology that has been introduced into Android location is something called raw GNSS measurements. Now, raw GNSS measurements, if you look it up on Google, it will bring you a whole different set of pages interacting on how to get to the API. But essentially all this is sensor data that you're getting. We use different measurements values, such as what is the noise of the satellites that's being recorded, what the signal phase of the satellite signal coming down. Using a combination of these, you can improve your positioning fix quite remarkably. And all of this is enabling essentially what you get as the location result, or get location fix. Another technology, though, as well, that's been enabled is Broadcom, which I'm sure you've probably heard of at the very least, has released a new chipset from last year. And I've got the smartphone in my pocket. This is the first smartphone to be using this new chipset. It's the Xiaomi Mi 8. And what this allows you to do is you can pick up multiple signals from the same satellite. And these multiple signals enable you to be able to get more measurement data, which eventually, combining all those measurements up, can give you a much better location. And this is kind of a nice little illustration. You've got all of these different satellites They've got different signals being produced. You've got at different frequencies. So you've got the L5, E5, and then normal frequencies. And when they're coming together, you get this nice, essentially, crossover point in the center, which is what the Xiaomi Mi 8 and the Huawei Mate 20X was the second phone to actually enable this increased accuracy. But it's what we want in the GNSS sector or navigation sector. We want as many satellites, as much measurement data as we can to be able to enable a much more accurate position fix. And to look at the smartphones that would enable this, you can go to this developer.android.com, guide topics, sensors, GNSS, and there's a little table list that shows you exactly what data, what measurements can be acquired with that particular smartphone. And these are the three areas we're keenly looking at, is the carrier phase, pseudo-range, and L5, E5A. This is all GNSS stuff. What we're trying to do with Flamingo, which stands for, you can see we picked the name before we chose the acronym itself, fulfilling enhanced location accuracy in the mass market for initial Galileo services. And this is a big European-led initiative to essentially have an high accuracy positioning service where we're getting different correctional measurement data that will improve the positions, including the technology that is enabled by these chipsets, and then delivering an accuracy that our target is 100 centimeters or better, or what we're ultimately achieving is at least 50 centimeters or better. Currently with smartphones today, you are getting about, in the best case, 5 meters, and that's in an open sky. In cities, you're achieving about 20 meters level. But then you're probably asking, why do you need these sorts of accuracies? So as I initially introduced, when you're getting your position fix, if you've got a person trying to walk along a street, and the map is constantly churning out different position fixes, you don't really know what block you're walking on. You don't know if you're in a car and you've got using your smartphone to navigate you. You don't know what lane you're in, what lane you should be positioning yourself in. And for identifying the particular type of coffee store or restaurant that you want to go to, you'd want a much better accuracy to be able to navigate you exactly to where the actual entrance is to that store. And that's what we're trying to enable through this. So this isn't actually a nice video we made illustrating for an augmented reality-based application. So you're wanting to create in your environment, I'm sure you've all heard of the new Minecraft Earth that will be released, where you're inserting augmented reality objects in the real world, placed by particular persons at specific locations. When you've got 3 to 5 meters of accuracy, you can see that shed is basically jumping all over the place because you're using your smartphone's positioning fix and trying to insert your AR object into there. But if you've got about 0.5 meters, 1 meter of accuracy, which is what we're targeting with Flamingo, then you can achieve a much better augmented reality environment through that. And what we're doing, and we're wishing to engage with developer community, because this isn't our world, we're trying to enable it, is introducing a nice SDK styled in a way that's exactly like Android location, so it's just a simple change, and having new applications that can be enabled with these sorts of services. And we should be releasing this in the next week or two as an initial version on Git. And these are currently the devices we're playing with at the moment. The Xiaomi Mi 8, as I said, has the best sort of accuracies based on that newer chipset, but Huawei P10 and Samsung S8 also can enable this. And just going through the simple implementation, in terms of getting much more accurate data readings through Android, you need a set of permissions, access fine location in the internet, so you can receive some of the correctional data inside the app, targeting in the Gradle Java 8, and it's essentially a simple .aar file that you're inserting, and will enable you to have access to these algorithms and correctional services inside. And in terms of the actual implementation, it's just a simple Flamingo location callback, which will give you the latitude and longitude that you're wishing to receive. And then there's also just a simple registration to the server that will provide this sort of locations. But a lot of this is also detailed on the website as well to have you interacting with it. And this is just a simple mock-up that we're planning on uploading as well, where you can kind of see, essentially, this is just the code running, where you've got pink, which is Flamingo, and this is just going down what should be the track of what you're targeting. And you've got the Flamingo location and the Android location in there. But, I mean, I don't think this is a very nice way of showing what you can get out of having a much more accurate location, but it's just to allow developers such as yourselves to simply use the sort of service we're trying to enable. And this is an illustration of the difference between Android location, which is just producing the .get latitude, .get longitude, and essentially with Flamingo location we're doing the exact same thing. It's just a get latitude, get longitude, but it's just much, much more accurate. And these are illustrating more the sorts of applications that we're targeting. Also wishing to provide these as kind of an illustration tool on what sort of new applications that can be enabled with it. Surveying community. Surveyors' equipment actually costs about £50,000 on average for people walking around with these heavy sticks to try and survey it for different building sites and such. If people can just have their smartphone and take their smartphone out and survey a site, it's a massive, significant cost benefit. Pedestrian navigation for the visually impaired, so you're showing that street map. If you can have a visually impaired person know when they're about to reach a traffic light and not step out in front of a vehicle, then, and it's an amazing application that could change many, many people's lives. Fitness, for more accurate fitness. Statistics, as you're going for a jog. Vehicle navigation, tracking, and augmented reality, as illustrated before. And these are also some of the sorts of AR applications. So that Flamingo there is being inserted by the geolocation fix of the phone, and then inserting that sort of environment, that bird essentially, into it, surveying. And then this is our demonstration kind of augmented reality. So you've got particular boxes being placed in the environment, and the phone starts buzzing essentially when you go closer to a box. But you need that much more accurate GNSS fix, that navigational fix, to be able to enable that. And yeah, thank you very much. And this is another illustration that we've got of, this is in Leiden, in essentially illustrating why, if you've got a tourism app where you're showing where the statue of Rembrandt is, why you need a much more accurate location. And please, you can sign up to the flamingognss.com. You can get some updates on everything we're up to. And this is a big European GNSS agency, which is associated with the European Space Agency initiative to really introduce these sorts of technologies. And we're also holding an event on the 12th of November at Geovation in London. Please come along if you're interested with what I've spoken to today and get to access much more accurate navigation and see the sorts of applications that can be enabled with it. Great. Thank you very much. Cheers.